Hi everyone, welcome to my session, The Architecture of DevOps. Now you maybe want to ask me, what have architecture to do with DevOps? Because often when we're talking about DevOps, we're talking about things like culture, bringing people together, about delivering value. If we don't talk about continuous integration and continuous delivery, that was DevOps. But DevOps is so much more than that. This or similar picture is something that you often see when we're talking about DevOps. It's often called the DevOps loop or the feedback loop. It shows every phase from planning, coding, testing, deploying to releasing and operating and monitoring application in production. And we will iterate that continuously. That's why it's called the loop. I would say that we cannot have application in maintenance mode if we are a DevOps team. Maintenance and DevOps cannot coexist. With DevOps, we will continue to develop the application for the whole life of it. Of course, we can do that in different speed with different amount of developers. But it's not in maintenance, at least not in a classic way. If you put an application in maintenance mode, I would say it's dead. Or at least it's on its way to die. But if you break down the DevOps loop to a simplified image, we will get the core concepts of DevOps. Build, measure, and learn. We will build something, we will deploy it, and we will measure how the users are using it. And we will learn from that, and we will build improvements to make our applications better, better, and better. To deliver value to the users. And deliver value continuously. We want to deliver value fast, so we can make our applications better, better, and better. But we don't talk much about how to build those applications, so we can be able to deliver value continuously. That's why we're here today. I will talk about the architecture of DevOps. My name is Hindrikes. I'm a developer and architect. And for mobile and cloud solution, powered by Xamarin and Azure. If you want to learn more about Xamarin, as Vic said, you can read my book that I wrote together with my colleague, Johan Karlsson. I also like to record podcasts. I'm doing a podcast together with Johan, The Code Behind, and I'm also doing another podcast called App in the Cloud. I also like to do some live coding on Twitch from time to time. So if you want to know what I am doing, you can follow me on Twitter at Hindrikes. To understand why we need a DevOps culture, we need to understand some of the problems that we have when we are developing applications. When I say developing, I don't just mean writing the code. I include everything that the team do, the development team, including testing, project managers, testers, and so on. Everyone is a development team or a DevOps team. Of course, we will talk about code during this session, but we will start to talk about deployments and installations. An easy way to deploy is maybe one of the most important things when we want to deliver value continuously. And that's probably why many people are talking about DevOps like it was continuous integration and continuous delivery. So let's talk a little bit about continuous integration, CI, and the continuous delivery, CD. Why do we need that? According to me, there are two main reasons. Number one is to ensure quality. Even if we don't deploy all builds, there are a lot of winning by having continuous integration builds. We can ensure that we don't break others' code, and we can ensure running code quality checks and that we maybe not can do on our local machine. Of course, that depends on what application we are building. And if you have some application we cannot build on our machines because we have different CPU architectures and things like that. For me as a mobile developer, I often building in debug configuration, so I verify that I don't break other codes when I'm running my continuous integration build, because you often may have different configurations in your project. So you have debug, test configurations, and so on. So I always want to run the builds on all of those configurations to verify that I don't break anything, because some of the builds maybe are for running UI tests on, some are from productions. So if you only build in debug configuration all the time and waiting to build the production configuration, you maybe have a lot of errors for production configuration when you start with that and you want to deploy. Number two, and maybe the most obvious one, is that we want to have automated processes instead of a process with a lot of manual steps when we want to release code to different environments. If it goes in the role as a user, we will hate messages like this. Even if we are building application for internal use, user will hate messages like this. But imagine if you go into a website, you maybe want to buy tickets to the Britney Spears Union Tour, and they will show you this message. You maybe will be able to buy the tickets. And if you're running an e-commerce site, you will probably lose a lot of money every second that your website is down. So I would say that if we're building application that is public website, for example, it needs to be running 24/7. And even internal system, that's really important to have high user acceptance, because otherwise your application is the application that all users will hate. For example, as with 99% of all time reporting applications. I want to tell you a story, a true story, about one of the projects I have worked in, where we have a lot of problems with downtime, we have problems to deploy it. Yeah, we have every problem we could have, I think. But it was a couple of years ago, I joined the project. They already have about 7 or 8 applications in that platform, and we still develop new applications that should be part of a platform with applications that talked to each other. And it was a pretty big project. It was around 20 developers, I think, as most. We had automated builds, automated deployments, but just for some of the environments that we was able to control. The other environments, the staging environment where the customer tested our application, and the production environment, we don't have access to those. So what we have to do was to create an application package. We need to send it to them. We need to write instructions for it. Do you think they read the instructions? I don't think they did, because they never did the installations right. We always have problem. But before they could even start, the project owner had to communicate to all the users of the applications that they cannot use it on one day. Every time we wanted to release a new version of the application, they had to take all 10 applications down for one day. One day, they can use their primary work tool. So it's like that we could use Visual Studio for one day. So we couldn't do nothing. Maybe we can go play Rocket League or something like that instead, but that will not be very productive. But because they didn't read the instructions, we often get even longer downtimes than one day. So if we have had automated process instead, we should have been able to release the code exactly the same steps every time without risk for humans' mistakes. But it's not that simple. Automated process will not fix everything. It will make it easier to deploy, but there's still a risk to deploy a platform like this, especially when there are a lot of dependencies between the applications. This is a simplified overview of the platform. And not all applications are included. Not all dependencies are included. There were also a lot of Windows services and other strange things. But if I should show everything, there had just been lines everywhere, so I skipped that one. But if we want to do a change, it is one of those systems. We had to do changes in everyone because there were hard dependencies between them. So one changes in the building system, for example, affected in the other systems as well. So that's resulted in that we didn't do many updates. Even if we have updates ready, we didn't do them because it was too complicated to do them. Maybe a year maximum. But do we have to build our application like that? No. If you want to work with DevOps for real, we cannot build our application this way because we cannot deliver value continuously. You cannot deliver value each day, each week, or however often we want to do it. So it's better if we can have a more loose coupled architecture. Microservice architecture, for example, is very popular and hot right now. And if you do it the right way, it will solve one of our problems. But if you don't do it right, of course, it will be even more complex with a lot of microservices. But the key is to remove as many hard dependencies as possible and make the platform or application more asynchronous. So, for example, if we have two applications, application A and B, in this case it's two front-end applications. We can say that they're working with customer data. Application A only needs to show data, and in application B you can also update the data and add new data. So how can we build a good architecture for that? The first thing I should do is to put a service bus that we can put all our changes in. So when a user saves new customer data, it will be put in the service bus and you will get a 200OK back. And then we can add a listener to that service bus. For example, if you're using Azure, an Azure function or an Lambda in AVS, that will handle customer data and save it to the database. So now, if we want to update the logic, the code that handles the saves, we can do that without affecting the front-end application. So if the users can still work with the front-end application, they can save data and put it in the service bus. And when our listener, our application backend is up and running again, it can handle all of the updates and save them to the database. So even if we have downtime, it will not be a downtime that the user will know about. And if we add a cache that we can cache all the data in, so that both application A and application B can use, we can also always have the data ready for the application, even if the database is down, if the backend services is down, the users can read the data. Of course, they can have old data, but they can still work with it. So we can also add a listener to the service bus, and in this case, we have a service bus with a topic subscriber model. We can also have it with queues, but with queues, there can only be one listener. So I prefer, in many cases, to use the topic subscriber model. And as I said, in the worst case that can happen here, if the functions or the listeners that are written in our way goes down, is that there will be a delay for the applications to get the update. If we group those services together, we can say that this is a microservice for customers. And the application backend can be a couple of those services, so we will cover all other domains we have, and all the needs we have in the application. But we can update this one separately, we can update the functions separately, and we can update the database without affecting the front-end applications for the users. And if you have, for example, a NoSQL database, it will be even easier to update the database. For example, a document DB like Azure Cosmos DB. And not to forget, when we're using a service bus, it's really easy for other users as well to consume the data. So we can add a new listener. For example, if we have an analytics service that want to have all the data, they can also get it. And the service bus will guarantee that all the listeners always will get the messages, get the data when they are back, even if they have been down for a couple of hours. So this makes our application very scalable, but the most important now, when we're talking about a DevOps context, we are able to do updates without affecting the users. But what about code quality? You maybe think that it's not important when we're working with DevOps, because often when we're talking about DevOps, we're talking about deliver code fast. So maybe code quality is not important when if we can deliver business value. But I would say it's really important to have high code quality when we're working with DevOps. Okay, we maybe can deliver fast the first 5-6 times if we have bad code quality, but in the long run, if we want to deliver fast, we need to have high code quality, because if we don't have high code quality and a good architecture, there will be more bugs. And if we always have trouble after a new release, we will stop doing releases. It will take longer time between the releases. We will wait and ensure the quality. We will work longer with it. So it will affect the speed. So if we want to deliver continuously in the long run, we really, really need to have high code quality. There are a lot of processes that can help us with that. For example, things we can integrate it in our CI build. We can have unit tests. We can even have UI tests. We can have static code analytics and things like that. And I think it's the developer that is responsible for maintaining the test, even UI tests. If you're doing a new feature and you break all the tests, you are responsible to update them. Of course, we cannot have 100% code coverage maybe, but I think it's really important to have unit tests for the most important part of the application. And it's really important to have code reviews. If we're working with pull requests, I think is the best way to work. It's a natural way to have code review, both manual and automated code review. For example, as I said, we can have static code analysis. For example, we can have maintainability index, and we can have something that is called cyclomatic complexity, that measure how complex our code is, and then we can have rules for that. For example, if we have more than 10 different ways in code can execute in a method, we maybe need to refactor that one. It's easy to write big methods with a lot of code that run in different ways, but that will make the code more complex, and in the long run it will be harder to get new developers into the application, and if developers stop working with the application, we will lose some of the knowledge about it, and of course that will increase the risk for bugs. So to have good rules, code review rules, I think it's very important if we want to deliver high quality in the long run. And of course, we need to have good branching strategies, so we know what's are going out to the productions. We can have a master, for example, that always is what we have in production or what's are going out in production. That's one way that I like to work with, and also have one development branch that is the branch where the testers are doing their manual testing, and the developers will always work in a feature branch, so it will not affect others' code before it's ready, and you can do pushes to the branch without affecting other code. Of course, it can feel time-consuming to write tests, to write unit tests, but I promise you, in the long run, it's really worth it. But even if you had good processes for quality, assurance. It's hard to know how applications will behave when they are used by real users in a production environment. So I would say that when we're working with DevOps, the definition of done should be a feature is tested and measured in production. Before that, the feature is not done, because we don't know how it behaves before we have real users that using it. But even if we have done all those quality checks before it will release to production, it sometimes goes wrong. Maybe because that we have other data, more users, or other dependencies in production. So then we need to handle that situation. Then we have a couple of options. We can do a rollback, but if you decide to do that, I hope you have a good architecture that makes it possible to just roll back the part of our application that you will have problem in. If you go back to this image, where we need to update all systems or application at the same time, we had to roll back all applications, all databases, all websites, all Windows servers, everything to get the application up and running again. And that took very, very long time, because everyone that have restored a database, especially for a big application, know that it takes a long time. And if that is for a public website, for example, you will lose money. Your company will lose a lot of money. But why do rollbacks? Especially if we're dealing with databases. Rollbacks takes, as I said, a long time, and we maybe need to upload a database again to the service because we have saved it on a storage somewhere, and we need to restore it. So in many cases, they are probably easier to just fix the error instead of rolling back the code and rolling back the database. So I would say that we should focus on fixing the errors. In many cases, just a few lines of code that need to be changed and built and deployed. Or we can run a SQL script just to fix the errors in the database. And that will, in many cases, be much faster than just to restore the database. If we are having a website, an API, it's probably easier to do a rollbacks, especially if we don't have done database changes. If we're working with Azure, for example, we have something that is called slots. So we can have a production slot, and we can have a slot with a new code, and we can just swap between them as much we want. So fix the error. Don't roll back if you don't have to. So if we accept that we can have errors in our application, or we should not accept errors, but the case is we will get errors sometimes. Even if we have all the code quality checks, there will be errors time to time. So it's really important when we're doing release that we can follow up the release. And we maybe don't need to release the code to every user all the time. We can do something that is called stage rollout. We can start to roll out the new code to a small amount of users. And if everything goes well, we can start to roll out into more users. This can be done in different ways. If we go back to Azure App Service and how that works, we can have those slots, and we can say 20% of the traffic will go to this slot instead of the old production slot. And then we can increase the percent of users who will get the new code if everything goes well. If we, for example, deploy an app to Apple App Store, we can say roll it out over 7 days, and Apple will handle that for you. On Google Play, we can do this manually. We will say 10, 20% or whatever we want will get the updates if they have automated updates available. And this makes it possible for us to monitor the application, see if we have errors, see how the users using our new features before, and we get it before everyone have it. And if we have some problems, we can find them, we can take back the updated version, and we can fix it and deploy it again before it will affect all our users. One other thing that we can use is something called feature flags that I think is really important when we're working with DevOps, and I will talk more about that later. But if we have a new feature, we can say that only this group of users will have it enabled. So we can try it on those users as well. Even if we have deployed all the code to production, we only make the new code available to some part of the users. For small updates or bug fixes, this may be not relevant, but if we have new big features that we want to deploy, I would recommend you to don't roll it out to all the users at one time. Do you remember that I showed this one in the beginning, build, measure, learn? It sounds simple. Of course, you have to think about what we want to measure. And probably in a big company, we have business analysts. This also is interesting what we want to measure and what metrics we want to have. But I think it's important that we integrate this in applications early. So we don't wait to building the monitoring part and the part of the application that will collect metrics. On server side, it's probably more easy compared to the client side, because on server side, we're more interested in performance and errors. But on a client, we're interested in more, where we want to measure how the user using features, how many users that using that page, so we know where we can put the resources to make the application better. And as I said, it's really important to do that from the beginning. And if we have too much data, that's not a big problem. Of course, we need to keep GDPR in mind and be careful about what personal data we are logging. But I try to do that logging so anonymously as possible. So even if we don't know the requirements from the business analyst, they can just create reported of the data we have. If we don't have enough data, it's much harder to create a report than if we have too much data. So I think all applications should have support for this if you're going live with new big features, so you can try it and know how the users will use it. We'll come back to feature flags now. I think it's really important here to have it. If you're using Azure DevOps, for example, you have probably seen a lot of these feature flags you can opt into to test new features. You can do it that way, or you can say and decide what user you want to test it for. For example, if you have users in Sweden, you can try these new features only for them, and if that works well, you can turn it off for the rest of the world. Or you can ask the user to opt in to this preview features. And if you do so, it will be easier to ask them for feedback as well, because if they have opt in to it, they are more open to give you feedback. So I think that's a good way to even know what the user is thinking about the application. Of course, you can measure, but there are also cases where you want to know how the user and what they think about the application, because that could be different from what the metrics showing. So why do we fail with DevOps? Because I think many projects that think they're working with DevOps, or they're trying to work with DevOps, they will fail. And there are a couple of reasons that we can see that often is the case in those. So one thing is they have a bad architecture. In many projects, architecture is just something you do in the beginning of a project. I have been in a couple of those where they ask me, can you do 8 hours architecture and set the architecture for the application in the beginning? And then they just started to work with it, and they don't think about this architecture thing anymore. But I think it's really important to have an architect during the whole project. maybe not a full-time architect, but someone that can be there and supporting when they need to do architecture decisions, because there are always things that you don't know about when you're starting to develop an application. And you can maybe have a complicated deploy process, and there could be different of reasons for that. You maybe not have good CI/CD, and that will make it harder. You maybe not have the right permissions to do automated deploys, especially if you have different teams that are working with development. You have another team that are working with the infrastructure. You maybe have another team that is responsible for the physical server. So what DevOps is about is to bring those people together, so we can have one big team with all, and we have all the capacity in one team instead, so we can have easy to deploy. And the other thing is that we don't have good quality checks. The things we deploy in the beginning of a project is not good, so we're becoming afraid for releasing. And the one that takes the decision, they maybe want us to do extra tests and just waiting a little bit, make the application a little bit better before we can do it. But if we have those processes from the beginning, we can have good code quality, we have unit tests, we have UA tests, we can be more comfortable to make the deployments from the beginning, and that will make us able to deploy fast. We can deploy several times a week, several times a day, if we have good processes, including manual testing and automated testing before we're releasing. Okay, so let's do a summary, what we have talked about today. Architecture is really important. You need a loose-coupled application without hard dependencies to make it very easy for you to deploy new code to production. Code quality is really important, at the same reasons with architecture. If you have bad code quality, you will make it hard. It will be harder for you to deploy in the long run. And test is important. So everything that is important for delivering value continuously have with quality to do. So if you say that quality not is important when we're talking about DevOps, you will not succeed. At least not in the long run. You maybe can do good releases the first year, but if you want an application to live for 5, 10, 20 years, you need to have good architecture, good code, and good processes. And that's the most important part to make DevOps work in real life. And of course, as I said, the process is important. Thank you for me. If you have questions, you can ask them to me now, or you can come to me and talk after this. Thank you.
Why come after when we've got Nigel? Thank you, Daniel. Daniel, sorry.
Yeah, whatever you want.
Ooh,
the unit.
I like it. Does anyone have any questions? Want to get their hands on Nigel? Oh, this is going for it. Was I told to be a bit more gentle? Carnage.
You like football, you should.
I was going to, but know your limits.
Check mic 1, 2. Yeah, it works. Thank you, Daniel, for the interesting speech. DevOps is such a broad topic.
It's really broad.
Yeah, you've touched basically all the things that come into mind when talking about software development, and you've finished with all the things that you think are most important. Yeah. What is not that important in terms of DevOps? So,
what's not important? Okay. Really hard question. Sometimes when we talk about DevOps, they think it's important to say that all in the team can do everything. For me, it's not important. The most important thing is the team can do everything. So everyone in the team should not be able to do everything. So that's not important, and something that we talk much about when we're talking about DevOps. I think it's a big misunderstanding.
Cool, thanks.
Thank you.